Okay, so we're going to go over the vertex form of quadratics. Now, we have to know like the original vertex form, which is usually written as y is equal to, and then that'll be for lines, yeah. So that's for a linear equation, but quadratics are a little different. Y equals a, then x minus h squared plus k. So these different letters all stand for something. K stands for vertical, so up and down translation, so moving an entire parabola up or down. H stands for moving an entire parabola left and right, so horizontal translations. And then A deals with vertical, but I'm going to put S and C because that stands for stretches and compressions and flips. Okay, so A does quite a bit. So we're going to talk about how those numbers affect and what we mean we're affecting from. So an original parabola is y equals x squared. In this parabola, its vertex is at 0 and 0. Okay, so that's an important point. Okay. From there, the best way to draw one of these is to count from the vertex 1 over and then square that number. Okay, so 1 squared is equal to 1. So that means I go over 1, up 1.
Yeah.
So here's 1 point. So that's a point at 1 and 1. I do the same thing to the left. Parabolas are symmetrical. So I go negative 1. Well, negative 1 squared is still positive 1. So I go to the left 1, and I still go up 1. So I have negative 1 and 1. Okay, so these are our original points of a parabola. It's really important that we kind of try to memorize them. Okay. Then from here, I go back to my vertex. I always start at my vertex. Okay. I then go over 2 spots. Well, 2 squared is equal to 4. So that means I go over 2 and up 1, 2, 3, 4. That's where the next point is. Okay? And that's
Are these our original points, or we're making up these?
No, these are original for this specific parabola. Okay, this
okay,
equation here, this is what it's going to look like.
Oh, okay.
And I do the same on the left. I go back to the vertex. I go over 1, 2. So that's negative 2. Negative 2 squared. Well, that's still positive 4. So I go over negative 2, 1, 2, and I go up 1, 2, 3, 4. So if you look, they're symmetrical, the points. They're the same on both sides of the y-axis. Okay? We'll do one more. And you can continue this pattern forever.
How do you know what to do if like x to the power 2, that doesn't have a new number? How do you know what to do?
Because, so what that means is the a value is 0 here, the h is 0. So this is the original parabola, so we have to memorize this one. So you should have this one memorized.
Oh.
Okay, so that's why I'm writing all the points out so that you memorize it. And this coordinate here was at negative 2 and 4. Okay, and then finally, if we go back to the vertex again, I go over 3 points. Okay, 3 squared is 9. So I go over 1, 2, 3, and up 1, 2, 3, 4, 7, 8, 9. That's the next point. Okay, now you could have done all this, and then 3 to the left will also be 9 up. It's symmetrical. So this is our original parabola. Okay, so when we talk about transforming or moving a parabola, we're always talking about from these points. 3 and 9, and the other one is negative 3 and 9. Now, you could have done this by making a t-table chart, right, and plugging these values in, negative 3, negative 2, negative 1, 0, 1, 2, 3. But this is a quick way, if you remember that the vertex is at 0, 0, it's a quick way to draw the rest of the points. Okay, I know I didn't draw that perfectly, but that's the idea. So this is really important that we memorize this one, because when we talk about translating it, we always talk about translating it from this guy here. Okay, so let's say we got a parabola now. They've given us an equation that says y equals, here we go, negative 0.5 x minus 5 squared plus 3. Okay, we have to point out what our a, our h, and our k is. A is negative 0.5. Okay, h is our negative 5, and k is our positive 3. Okay, so these are our 3 movements from this one. So we're going to go through a lot. Remember I talked about a being compressions or stretches.
Mm-hmm.
So,
Flips?
yeah, or flips. First of all, when a is a negative number, it flips. Okay, so the entire parabola is going to be facing the other way when I say it flips. It's going to go like this. Okay. Also, we have to figure out the value of a. If a, sorry, when I talked about a here, a is 1 in that case. Here it's 0.5. So when a is less than 1 but greater than 0, it's vertically compressed. So what does that mean, vertically compressed? Well, I want you to think
like
of it.
This?
Yeah, it's being squished. So if, say there was a flat line on this, pushing this down, it would make this wider.
Mm-hmm.
That's what compressed means.
Mm-hmm.
If it was stretched, think of it like an elastic band and someone's pulling these up. And if you pulled them up, it would make it thinner. Okay?
Oh, okay. Mm-hmm.
So you stretch a when a is greater than 1. That's a stretch.
So you make it thinner.
Yeah, exactly. So in this case, a is less than 1, so we're going to compress it. And it's negative, so we're going to flip it. Now the easiest way to go about this is redrawing it the same way, but using this a value. So what do I mean by that? The vertex isn't going to move. The vertex being the highest or lowest point. It's still going to be at 0, 0. And we're still going to use our same pattern. I'm going to go over 1, and then I'm going to square that number, but then I have to multiply it by a. So there's a few steps we have to do here.
Square what number? The 1?
Yeah, what we go over by. So because we went to the right one, that's positive 1. Okay, so we're going to make a little chart here when we go through it.
Okay.
When I go over 1, so I go positive 1 squared times a. Well, a in this case is negative 0.5. So first of all, 1 squared is 1. So now we have 1 times negative 0.5. That's going to equal negative 0.5. What does that mean to us? It's a bit confusing. What that means is when we go over 1, we go down, negative means down, and we only go, 0.5 is a half. So we only go down a half of a spot. Okay, so this is how we draw our point. And remember we said they're symmetrical, so I would do the exact same thing on the other side. We always try to deal with our a first before we do h and k. Okay? Then we go back to the vertex, we go over 2 points. We do the same idea. I take 2, and I have to square it, and then I have to multiply it by my a value, which is negative 0.5. So 2 squared is 4 times negative 0.5. You'd use a calculator here. I'm going to just tell you that it's negative 2. So what that means is we go from the vertex over 1, 2, and negative 2 means we go down 2. So 1, 2. Here's our next point. Okay? And it's symmetrical on the other side, so over 2, down 2. Do the same thing with the value of 3. 3 squared times a. Negative 0.5. This is how we figure out how to draw the y values, the y coordinate. 3 squared is 9 times negative 0.5. That's going to be negative 4.5 if you put it into a calculator. So we go to the vertex, and we go over 1, 2, 3, and we go down 1, 2, 3, 4.5. It's kind of in the middle there, right? And then we do the same on the other side, over 3, down 4.5. It's symmetrical. Well, it looks like we can draw more, because remember, after 3, it looks like we would have been off the chart, but because this is compressed, we might be able to fit another. So let's try 4 and see if it works. Let's try moving 4 from the vertex. So 4 squared times negative 0.5. That's going to be 16 times negative 0.5. And that's going to be negative 8. This is great. So we go over 1, 2, 3, 4. And we go down 8, and that's going to be roughly here. So what do we want to look at? We do the same on the other side, over 4, down 8. And now I just kind of connect my dots, so this is what it's going to look like. Now, it doesn't look like a big difference, but it is compressed compared to the one before. The one up there is a little thinner than the one down here. But that's only the A movement. We still have to do the H and the K. Now, luckily, the H and the K are a little easier. K deals with moving it up or down 3 points. So because K is positive 3, so when k is a positive number, we move up.
Mm-hmm.
When k is a negative number, we move down. So it works out great. K is positive 3, so we go up 3. So I take every point, and I go up 1, 2, 3. Here I go up 1. So this is a half, right? So it's harder to do. 1, 2, 3. 1, 2, 3. This goes up 3. 1, 2, 3. 2, 3. This goes up 3. 1, 2, 3.
I get that.
Yeah, so this is a little easier. 1, 2, 3. And this one goes up 3. 1, 2, 3. 2, 3. So this is now our K movement. We've done A and K. So this has been flipped and compressed and moved up. And then there's one last one we have to do, H. H does left and right. Now, H is a little different from K. When H is a positive number, we don't go in a positive direction.
You have K.
Yeah, I know. I'm going to fix that. Sorry. H. When H is positive, you would think positive is to the right, but it's counterintuitive. It's the opposite. So we move it to the left. When H is negative, we go in a positive direction. We go to the right. So we have -5. That means we go to the right 5 units. So let's take this green one now and move everything to the right 5. 1, 3, 4, 5. There's a point. This guy goes 1, 2, 3, 4, 5. This guy goes 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This one, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It can be hard when there's so many on a graph, right?
Yeah.
And then the last one, 1, 2, 3, 4, 5, which is here, and this guy will be here. So our final graph is the blue one. The blue one is what we're trying to really look at here. Let's open up this page a bit. Okay, this is this equation here. This graph from the black one, okay, it's been flipped and compressed. That was what we did in red. We turned it the other way and compressed it a little.
Oh, so this is that right here, no?
Yeah, that looks like it. That would be...
yeah, because it passes the 2 right there.
Mm-hmm. Oh, but they go up 3 and over 5. 3 and over 5. Yeah, there you go. So that's what you're looking at there. So, yeah, like we said, we flipped it and compressed it. We moved it up 3 units, and then we moved it to the right for 5 units. And there it is. Now, the other good thing about this is I just want to point it out, the vertex. Okay, the vertex is the highest or lowest point. So here's the vertex of that. The coordinate of that vertex just so happens to be right now at 5 and 3, which is really important because they're really closely related to H and K. In fact, the Y value is the K. Okay, so it's 3. The Y value will be 3. And the H value will be the opposite for the X. So because the X was -5, it was +5. So for the vertex, you can relate the vertex right to these things. Okay? Now,